Boiling mechanisms. Application of the principle of heat transfer by boiling has taken a leading place in the industrial world, in particular in both nuclear and conventional power plants. Boiling, a two-phase liquid-vapor system, is an excellent means of transferring heat and an efficient thermal vehicle, and is therefore frequently applied for cooling functions. This boiling phenomenon can exist in various typical situations linked to the geometry and the nature of the flow, natural or forced convection, and the characteristics of the heating surface, imposed heat flux density, imposed wall temperature, or an intermediate situation. In a large number of applications, these heat transfer processes must be under permanent control, since without this, boiling could lead to hazardous situations. It's therefore essential to simulate the overall thermohydraulic behavior of the installations, and to understand the local phenomena involved in the zones in question. Characterization of these phenomena at both a macroscopic and a microscopic level in order to analyze the basic mechanisms is therefore essential. Cooling can be impaired, at which case the wall can be damaged or even destroyed. At a macroscopic level, the pool boiling mechanisms are described by Nukiyama's curve, which shows how the heat flux exchanged varies with the difference in temperature between the wall and the fluid. It also reveals a limiting value for heat flux, beyond which the wall temperature suddenly increases. The boiling crisis, which can lead to burnout, makes an entire part of the curve inaccessible. Studies have shown that the characteristics of boiling depend on a system in which the surface conditions, and more particularly the roughness conditions, play a fundamental part. A microscopic analysis shows that in the nucleation phase, the large sites are the first to be activated. Certain sites produce bubbles continuously, whereas others do so only intermittently. It would even seem that an active site helps to activate another site nearby. The presence of two sites close to each other means that the various phases of coalescence can be observed. Nucleation involves two principal mechanisms.